Imagine predicting who survived the Titanic without training a single model. No neural networks, no logistic regression, no fitting, no optimization. Sounds impossible, right? It's not. Because sometimes the answer isn't hidden inside a complex algorithm. It's already sitting inside the dataset. You just need to know how to look at it. By exploring the data carefully, we can uncover patterns that tell us who is more likely to survive before ever touching a machine learning model. By the end of this video, you'll truly understand exploratory data analysis, or EDA in short, how to explore your dataset, uncover hidden patterns, and see which features actually drive survival. You'll also learn how to summarize data using GroupBy and aggregation, how to visualize patterns with matplotlib, and how to interpret insights manually without training a model. No models, no training loops, just insights from the data itself. Think of a dataset like a giant classroom of passengers. Each row is a student, each column is a trait. Age, gender, class, ticket fare. If you want to know who passed the test, you could just calculate averages for each group. Boys versus girls, first class versus third class, kids versus adults. That's exactly what we'll do with Titanic survival. Groups summarize and visualize to see who had higher odds. Let's head over to VS Code and explore the Titanic dataset to see which features actually predict survival. Here we have the classic Titanic dataset. Let's focus on a few important columns that are likely to influence survival. Survived tells us whether a passenger made it, while gender, passenger class, and age are characteristics that can help us see patterns. By examining these features, we can start to understand which factors mattered most before even using a model. Now that we've looked at individual features, let's combine them and start summarizing the data to uncover patterns. Next, we'll implement GroupBy and aggregation to calculate average survival rates for different groups of passengers. This will help us see which characteristics actually impacted survival. In this code, we're using GroupBy and mean to summarize survival rates across different groups. The first line groups passengers by gender and calculates the average survival for each group, showing us whether men or women had higher chances of surviving. The second line does the same for passenger class, so we can see if first class passengers were more likely to survive than those in second or third class. Finally, the third line combines both gender and class, giving us survival rates for every combination. For example, first class women versus men in third class, so we get a detailed view of which groups were most likely to make it. All of this lets us uncover meaningful patterns in the data without ever training a model. Let's run the code. Now that we've run the code, the numbers tell us the story very clearly. Looking at survival by gender, we see that about 74% of women survived while only 19% of men did. That's a huge difference and immediately highlights that gender was a major factor. Next, survival by passenger class shows that first class passengers had the highest survival rate at roughly 63%, second class around 47%, and third class only about 24%. So class also had a strong impact on survival. Finally, when we combine gender and class, the differences become even more pronounced. First class women survived almost all the time, about 97%, while women in second class also had very high survival, around 92%, and women in third class were at 50%. Men, on the other hand, had much lower survival rates across all classes. First class men at 37%, second class men at 16%, and third class only at 13%. These simple aggregations reveal patterns that a model would have to figure out automatically, but we can see them directly. Women and higher class passengers had much higher odds of survival. This is exactly the power of EDA, understanding which features matter before ever training a model. Now that we've summarized the survival rates with GroupBy and aggregation, the next step is to visualize these patterns. Visualizations make the differences between groups immediately obvious and help us spot trends at a glance. Let's create some bar charts and a heat map to see survival rates by gender, by class, and by the combination of both. Let's break down what's happening in this visualization code. First, this bar chart shows the average survival rate for each gender. This makes it instantly clear which gender survived more often. Next, this bar chart does the same thing for passenger class, showing survival by first, second, and third class. Finally, the heat map combines both features. We create a pivot table in this line, which calculates the mean survival rate for every combination of gender and class. Then our heat map turns that table into a colored map, making patterns across multiple features immediately visible. These lines together let us see feature importance visually and spot the groups that were most likely to survive. Let's run the code. First, let's look at survival by gender. The difference here isn't just a gap, it's a chasm. You can see the female survival rate sitting high at nearly 75%, while the male bar struggles to reach 20%. This confirms that in the Titanic dataset, gender is likely your most powerful predictor. Now, look at passenger class. It's a literal staircase of survival. As the class number goes up, meaning the ticket price went down, the survival rate drops significantly. If you were in first class, your odds were more than double those of a passenger in third class. This tells us socioeconomic status was a massive factor in who made it to the lifeboats. The real magic happens when we combine them in this heat map. This is where the patterns really jump off the page. Look at the top left corner. Those deep red cells show that women in first class and second class had a near certainty of survival, over 92%. Now look at the bottom right. Deep blue shows that for men in third class, survival was incredibly rare, at only 14%. The most fascinating insight? Look at women in third class versus first class men. Even though first class men had the highest status, their survival rate of 30% was actually lower than the 50% survival rate of women in the lowest class. We didn't need to train a single model to find this interaction between features. The data just handed us the answer. What we just did is called Exploratory Data Analysis, or EDA in short. EDA is the foundation of every serious machine learning project. Before you ever split into train and test sets, before you tune hyperparameters, before you argue about model architecture, you should understand your data this clearly. EDA helps you identify which features actually influence the target, detect interactions between variables, and build intuition about what your model should learn. If we trained a model on this dataset now, we'd already expect gender and class to dominate. We'd expect strong interaction effects, and if the model didn't reflect that, we'd know something is wrong. That's the real power of EDA. It turns modeling from guessing into informed decision making. Here's the rule I want you to remember. Don't train first, explore first. If you don't understand your data, your model is just guessing faster. EDA is where you discover which features matter, where interactions live, and what your model should learn before it ever sees a training loop. If you skip this step, you're not doing machine learning, you're doing trial and error. Explore first, model second, always. If this shifted how you think about machine learning, make sure you're subscribed, because this is how real machine learning is done. Thank you.